Green grass is usually connected to water, soil, sunlight, and months of care. But what millions of players stand on today never grew from earth. It was engineered.
Grass failed faster than matches happened.
This grass doesn't wait to grow. It arrives ready. And before it reaches the field, its journey begins inside the factory.
After every tournament, fields stopped working.
Repairs took days, while competition schedules didn't wait.
Natural grass demanded watering, even when no games were being played.
Maintenance costs increased, but results still remained temporary.
More time fixing grass, less time playing on it.
The first synthetic blades were not green. Color came later. Structure had to be perfected first. Once shape was stable, color engineering began. Batch by batch, the blades became closer to real grass.
This was the beginning of engineered turf, replacing natural ground.
The flow rate seems stable now. Yes.
These bags contain the base polymers, polyethylene and polypropylene. They are stored carefully because even slight moisture weakens the fibers. Only dry material enters production, and every batch is tracked to maintain consistent quality. These powders decide whether the turf survives years of outdoor exposure.
Check the viscosity reading on
A very small amount increases lifespan up to 8 or even 10 years. UV blockers prevent fading, and heat stabilizers stop brittleness.
We need to increase the magnification on the left quadrant.
Adjusting now.
Before shaping begins, the durability of the turf is already prepared here. The pellets enter the heating chamber where temperature rises above 400 degrees.
Viscosity looks good.
The polymer liquefies and long strands begin forming. The shape is visible, but still soft, unstable, and not yet usable. When these strands enter cold water, their shape locks instantly. Rollers keep every strand separated so they don't fuse. This is where true fiber structure forms, because even seconds of delay can warp and weaken the material.
As the fibers move through the rollers, the molecular chains begin to straighten. This alignment enhances the fiber's tensile strength and elasticity. But stretching must be controlled. As tension rises, the fiber approaches its limit. Too much stretch makes the fiber brittle, causing it to break. In this stage, stretched fibers are collected and organized for the next phase. This is organized fiber, precisely layered and ready to become turf.
A clean and consistent roll ensures stable feeding in the weaving process. Skilled operators monitor the winding process to maintain smooth production flow. A clean roll means smooth weaving ahead. This is the stage where turf begins to take shape, where fibers meet the backing.
Each needle pushes fibers downward, forming loops that anchor beneath the surface. Every loop becomes a root, giving the turf its anti-pull strength. With each pass, the turf grows steadily, row by row, loop by loop. What was once thread now begins to look like a field. This stage adds the strength layer that permanently secures every fiber. Liquid latex spreads across the base, binding the fibers to the backing. The adhesive penetrates deep into the root zone, creating a secure hold. Inside the heating tunnel, the latex cures and solidifies. Once cured, the fiber roots are permanently locked and cannot pull out.
Maintenance costs increased, but results still remain temporary.
Drainage begins with precision. Every punch must prepare the turf to release water efficiently. Each hole forms a pathway. Too few, and water lingers. Too many, and the sheet loses its strength. Spacing controls performance. The balance ensures water escapes while the turf remains structurally firm. Now the sheet proves its purpose. Water must travel through without hesitation.
Only surfaces with consistent drainage patterns graduate toward the field.
Under these lights, even the smallest height shift becomes visible. Precision decides acceptance. The system compares every strand. Any deviation beyond tolerance means immediate rejection. Fibers must resist tension. The surface has to endure the same stress an athlete delivers with every step.
Rough contact is inevitable. Durability here determines how long the field survives real gameplay.
Only surfaces that withstand every test continue forward. There is no second chance in inspection. The final shape takes form. Sheets become massive rolls, ready for transport. Every roll receives its identity. Tracking ensures it reaches the right stadium or facility.
Secured on pallets, each roll is stabilized for long-distance movement. From this dock, the journey expands. These rolls travel thousands of kilometers around the world. Destination may differ, but their path begins here, leaving the factory to become future playing fields. Unrolled across raw ground, the surface begins its transformation into a stadium-ready floor. Layer by layer, infill fills the gaps, giving stability, weight, and natural movement to the turf.
Leveling machines finish the groundwork, creating the flat, fast surface athletes rely on. Here, engineered fibers behave like natural grass, supporting every sprint, slide, and strike.
What began as sheets in a factory now stands as a field, built for thousands of matches.